Hello class, welcome to our discussion today. We will continue our solution to some examples of derivative of hyperbolic functions. So this time we are going to solve this problem number 4 or example number 4. So given differentiate r of t equal to tangent of t plus the product of t squared and hyperbolic cosecant t. Okay, so again, for our solution, first we need to copy. We have to copy the given. So we're given r of t equal to tangent of t, then plus t squared times the hyperbolic cosecant of t. Okay, so next we have to inspect the given. So with our first term, so this is the trigonometric function because we don't have h here. We only have tan or tangent, and we don't have h. So you might ask, oh, where is h? So it's really exactly tangent of t. So there's no h here. So it means that this is the trigonometric function. Okay, and if you look at the second term, so the second term is composed of two factors. We have t squared and the hyperbolic cosecant of t. Okay, so differentiating, so we have r prime of t. Okay, so the prime here indicates first derivative, or it means that we are doing now the differentiation. So we have meaning we are taking the derivative of r with respect to t. Okay, so this is equivalent to this part here, class. This is equal to the derivative of r, all right, with respect to t. Okay, so we have the derivative of the whole thing, no? The tangent t plus the product of t squared and the hyperbolic cosecant of t. Okay, so derivative of this with respect to, so this time, class, we don't use x anymore because our function is a function of t. So with respect to t. All right, and then applying the sum rule together with the product rule. But before that, the product rule, let's perform first the sum rule. So we have to differentiate each of this term individually. So the derivative of tangent of t with respect to t, okay, then plus the derivative of the product of t squared and the hyperbolic cosecant of t with respect to t. All right, so for the first term, let's recall our derivative of trigonometric function tangent. So what is the derivative of tangent? So we have the derivative of tangent u with respect to x is equal to secant squared u times the derivative of u with respect to x. Alright, so if the function is in terms of x, but since we're given function of t, our function is a function of t, so we have the derivative of tangent t with respect to t, so this will be secant squared t times the derivative of our u is equal to t, so derivative of t with respect to t. Okay, so that is equal to 1, no? dt over dt is equal to 1. Okay, so using that formula, so for the first part, so we have secant, no? We have secant squared t. Alright, then plus, if you look at the secant term, this is composed of the product. So this time we are going to use the product rule. Okay, so what's the product rule? So product rule is derivative of u times v with respect to, so this time our variable is t, so we will use t. So with respect to t, so this will be u times the derivative of v with respect to t, then plus v times the derivative of u with respect to t. Okay? Now it's a matter of finding what is our u, what is our v. So in our given, so actually this is our u. Okay? So this is our u, and this part here is our v. Okay? So therefore, u is equal to t squared. So when you take the derivative of u with respect to t, so this time we're going to apply the power rule. Okay, so power rule. What is power rule, class? You can still remember, if you have derivative of u to the n with respect to x, so this would be n times u to the n minus 1 times the derivative of u with respect to x. So this is actually the general power rule. Alright? So here we have derivative of t squared, so we have 2 times t times the derivative of, ang u is t, so the derivative of t with respect to t, which is dt over dt is equal to 1. So 1 times 2t is equal to 2 times t. Alright, so that is our du over dt. Then next, we have to find what is our v. No? Our v is hyperbolic cosecant of t. Okay, so what is the derivative? So what is our formula here? So derivative of cosecant. So the formula of the derivative of cosecant. So what is the formula of the derivative of hyperbolic cosecant? So the derivative of hyperbolic cosecant of x with respect to x is simply equal to minus cosecant hyperbolic x, then times hyperbolic cotangent x. Alright, so you may put this inside the parenthesis or you may not, so that's alright. Okay, so we will use that formula for our dv over dt. So derivative of v with respect to t is equal to, so following the formula, so this would be minus cosecant or hyperbolic cosecant of t, then times hyperbolic cotangent of t. Okay, and just simply substitute this into our secant term. Alright, so substituting, we have u, so our u is t squared, then times dv over dt, so our dv over dt is negative, right? This is negative hyperbolic cosine of cosecant of t minus the times the hyperbolic cotangent of t. So you just copy that one. So take note, this is negative, so you put this inside the parenthesis. So negative hyperbolic cosecant of t. So again, you may put t inside the parenthesis or you may not, so that would be alright. Okay, then times hyperbolic cotangent of t. Okay, then plus, so our v is hyperbolic cosecant t. Okay, okay, so let us check. So u times dv over dt, so our dv over dt is this one, so this multiplication class here, then plus v, our v is this one. Okay, then multiplied by du over dt, so our du over dt is equal to 2t, so this is times 2t. Okay, so this will be r prime of t is equal to secant squared t, then plus minus, so this will be minus t squared times hyperbolic cosecant t times hyperbolic cotangent t, then plus 2t. Now you can write this first, so there's no problem, this is just multiplication class, times hyperbolic cosecant t. Alright, then rearranging, so r prime of t equal to secant squared t, then minus, or you can write the plus first. Okay, so you can write this first, so plus 2 times t times hyperbolic cosecant t, then minus t squared times hyperbolic cosecant t times hyperbolic cotangent t. Okay, so this will be our final answer. Alright, I hope you have followed the steps class in solving this example. Okay, so let us check once again just to make sure that our answer is correct, or perhaps we missed something. Okay, so secant squared t, so this is correct for the tangent. And we have 2t times cosecant or hyperbolic cosecant t, then minus the product t squared hyperbolic cosecant t times hyperbolic cotangent t. Okay, so it's correct. All right, so thank you very much, and see you again in the, I think, one more example. Bye.